This is section 5.1, bisectors, medians, and altitudes. A median is a segment in a triangle that connects a vertex to the midpoint of the opposite side. First of all, a vertex is any intersection of two segments in the triangle. So a median is a segment that connects one of these vertices to the opposite side's midpoint. So for example, in this picture, this blue segment is a median. It connects a vertex to the midpoint of the opposite side. Altitude, a segment in a triangle that connects a vertex, just like the median, to the opposite side, forming a perpendicular. Perpendicular means 90 degrees. So this is an altitude. Altitudes can be strange. For example, if you have a triangle that is obtuse, it is possible in an obtuse triangle to have the altitude be on the outside of the triangle. For example, if we want to make the altitude from this vertex right here, it has to be perpendicular to this opposite side. For that to happen, we have to draw an auxiliary line, which is an extension of an existing line in our triangle. So then, I did that wrong twice. So then, the altitude in this would be this segment here, which is not actually inside the triangle. It is also possible for an altitude of a triangle to be part of the triangle. For example, if you have a right triangle, such as here, both this segment and this segment are both altitudes, this one and this one. That's because if you make a segment from this vertex to the opposite side, making it perpendicular, it's going to be this segment. Same can be said for this one. So altitudes can be, to sum up, on the inside of a triangle, on the outside of a triangle, or be part of a triangle. Angle bisector. A segment that bisects an angle in a triangle and connects a vertex to the opposite side. So let's say that this angle here gets cut equally by this blue segment. This blue segment is an angle bisector. Remember that one dash on each of these means that they are the same. So an angle bisector, an altitude, and a median, what they all have in common is that they are a part of a triangle and they go from the vertex to the opposite side. A perpendicular bisector doesn't necessarily have to even be in a triangle, even though it mentions a triangle here. Perpendicular bisector. A segment in a triangle that passes through the midpoint of a side and is perpendicular to that side. So let's say that this side's midpoint is here. To show it, put the same number of dashes on each side. This segment here is a perpendicular bisector. It forms a 90-degree angle and cuts the side in half. This is a perpendicular bisector. Notice it does not have to go through a vertex. It could, doesn't have to. Theorem 5-1.2. This theorem does not have a name. That's why it has this generic name. What do these numbers mean? This means we're in chapter 5. This means that it is the first theorem in chapter 5. And this point 2 means it's also the second theorem in chapter 5. I combine two theorems together with an if and only if, which means that we could take the hypothesis of the sentence and the conclusion of the sentence, and we could interchange them and it would still be true. So, theorem. A point on the perpendicular bisector, so in this case B is on this line. That line is perpendicular to this segment, and it cuts it in half because we can see it's the same on both sides. So B is that point on the perpendicular bisector. So it says it is that point if and only if it is equidistant from the endpoints of the segment. So if I draw a segment from this endpoint to B, and I draw a segment from that other endpoint to be, those two segments have to be the same. So what do we have here? We have an isosceles triangle. Here's what this theorem is really saying. In an isosceles triangle, that means at least two sides of the same length, if you draw a median from the vertex angle, that median will also be an altitude. Moving forward. Draw and label a figure to illustrate each situation. Segment PT and segment RS are medians of the triangle PQRS. I got triangle, triangle. I just realized that. That's a double triangle. It's meant to be a single triangle. My apologies. And those medians intersect at V. Let's first draw a triangle. Doesn't tell us what type of triangle it is. So you can draw any old triangle you want. Label the vertices P, Q, R. Then I go back to the first thing that it said. Segment PT is a median. P is already here. T has to be the midpoint of the opposite side, because that's what a median does. It goes through the midpoint of the opposite side. Then we have segment RS as a median. We already know where R is. S has to be the midpoint of the opposite side of R, which would be over yonder. So that is median RS. Then it says and intersect at, and is referring to these medians. Intersect at V. So here in the middle where those two come together, we're going to call that V. Number one is done. Number two. Segment AD is a median and an altitude of triangle ABC. That is quite the segment. As theorem down here said, let me make this clear. Even though this theorem has numbers, you do not need, I repeat, you do not need to memorize the numbers for the theorem. If a theorem doesn't have a name, like this one doesn't, you just have to know what the words are in the theorem. You don't have to know it by name. So this theorem says, essentially, if you have a median that's also an altitude, then this has to be an isosceles triangle. So here we have the segment that's a median and an altitude, so that means this must be an isosceles triangle. The letters for the triangle are A, B, and C. The segment that's a median has an A and a D in it. Therefore, A has to be the vertex angle, which means B and C could be either of these. D, therefore, has to be the midpoint of the opposite side. This blue segment, segment AD, is now a median, because it intersects the opposite side. And to make it an altitude, I put a right angle. Done. Number three. Triangle DEF is a right triangle with a right angle at F. So let me draw a right triangle. Doesn't matter how you draw it as long as you have a right angle. This one does not have a right angle until I put it in. It says that that right angle is F, which means these other letters are D and E. I'm getting all three of those letters for here, with specifically F being the right angle. Then it says segment FG is a median. I know where F is. I don't know where G is. But then again, I do know where it is. It's the midpoint of the opposite side because FG is a median. Is G a midpoint? It's supposed to be. My picture doesn't show it yet, so it isn't until I show it. Same number of dashes on each side. Now it's a median. You don't need to write median in your notes. I'm just emphasizing it. So segment FG is a median of the triangle, and GH is the perpendicular bisector of the triangle. Is the perpendicular bisector of segment DE. So G, we already got. H has to be someplace else so that when we draw the perpendicular to this, perpendicular to DE, then that must mean the H is the intersection of that segment inside FE. Once again, it said segment GH is the perpendicular bisector. Since it goes through G, it's the bisector. Since it forms a 90-degree angle, it's perpendicular. Next, state whether each statement is always true, sometimes true, or never true. Number 4, 3 medians of a triangle intersect at a point inside the triangle. Well, that is going to be true no matter what. Don't believe me? Draw a random triangle. Can be obtuse, can be acute, can be a right triangle. Can be scalene, can be isosceles, can be equilateral. You name it. Make it any way you want. I'm just trying to somewhat prove it to you, using that word loosely here. A median intersects the midpoints of the opposite sides. Let me rephrase that. The median is the intersection of a vertex and the midpoint of the opposite side. So we can see in that picture, it sure looks like they intersect at the same spot. And it's inside the triangle. If we do that for this little fella here, similar thing happens. And once again, by no means is this a proof that this is true. But make about 1,000 of these triangles and you'll see they always intersect at the same point inside the triangle. So you don't have to do all that work. You just got to write true. Actually, true is not a choice. You got to write always. Number 5. The 3 angle bisectors of a triangle intersect at a point outside the triangle. That is impossible. That could never happen. Once again, if you draw some triangles, we're just going to draw one. All the angle bisectors, they will also intersect at the same spot. It will be inside the triangle. So it's difficult to draw this perfectly, bisecting an angle, trying. You have to show that they're bisectors by putting the same number of arcs on the angles that it's bisecting. So 5 is never. 6, the 3 altitudes of a triangle intersect at a vertex of the triangle. Well, this could happen. So sometimes then, let me give you an example of it happening, and I'll show you one that doesn't happen. So if it happens sometimes and doesn't happen other times, well then it's sometimes. This is an example of it happening. So this is an altitude, this blue segment. This green segment's an altitude. Goes from a vertex to the opposite side, forming a perpendicular. And then this purple one would also be an altitude. They're all intersecting at this same point right here. Here's another picture where it doesn't happen. So there's an altitude. There's an altitude. There's an altitude. They all intersect in the same spot, that's true, but it's not at a vertex. So that's why this is sometimes true. All right, here are the real problems. The first 6 were just to try to get you to understand what those words meant. Number 7, segment AD is an altitude of the triangle. When you're doing these problems, I'm begging you to underline terms or circle terms. So it says segment AD is an altitude. So that means this segment here intersects this side, forming a 90-degree angle. You need to mark that in your picture. The question is, find the length of segment BD. Now, when you're doing these problems, don't focus on the question until you've written an equation and solve for x. So we can write an equation from this angle here. This angle is 4x minus 6, and we know that angle has to be 90 because it's an altitude. If you solve this equation by adding 6 to both sides and dividing both sides by 4, you're going to get the x is 24. That's our first step. Actually, it's our second step. First step is putting the stuff in the picture, but I'm not going to label that as the first step. Then the question is find BD, and we know exactly what BD is because it tells us right here. BD is 2x minus 15. We can now replace the x with the 24. Simplify this expression. 2 times 24 is 48. Subtract 15 from that, and I believe you get 33. Have we answered the question? Find BD. We have. We got a two-step process. We got our steps labeled. Let's move on to number 8. Similar picture, if not the same picture. Segment AD is a median of the triangle. So now it's saying that this segment goes through the midpoint of the opposite side. So that means those are the same length. Find the measure of angle ADC. Well, we can't find the measure until we first write an equation and solve it. Well, since this segment and this segment are the same length, we can say that x plus 7 is equal to 2x minus 15. If we subtract x from both sides, we're going to get 7 equals x minus 22. And then if we add 22 to both sides, we're going to get x is 29. And if we focus on what we're trying to figure out, which is the measure of angle ADC, the picture shows us that's 4x minus 6. That's 4 times 29. You know what? I fudged up. My apologies. I don't know where this 22 came from. I think I subtracted 7 from both sides and then didn't write it on the left that I subtracted it. Anyhow, made a mistake here. If we had, originally we subtracted x from both sides. Now we're going to add 15 to both sides, and we're going to get x is 22. Put that into the expression 4x minus 6. 4 times 22 is 88. 88 minus 6 is 82. So assuming I didn't make another bonehead mistake, measure of angle ADC is 82 degrees. Did we answer the question? Sure did. Make sure that your writing is not as poor as mine. Number 9, find the midpoint of A, B. So that's the point that's halfway between those in a coordinate plane. We're going to use the midpoint formula for this, which is capital M equals an ordered pair. It's the summation of the x values divided by 2 divided by the summation of the y values divided by 2. This is a Greek letter sigma. It just means to add up the x values and add up the y values. Our x values are 2 and negative 5. Our y values are 4 and 8. Please note, this comma between the fractions means that those fractions have nothing to do with each other. You cannot combine them in any way. So if we add 2 and negative 5, we get negative 3. 4 and 8 is 12. This first fraction does not reduce. Second one does. So the midpoint of this segment, segment AB, is going to be the ordered pair negative 3 halves 6. One of those is hidden in one of the homework problems. It doesn't specifically say to find the midpoint, but you have to in order to figure that out. Number 10, find the measure of angle ABC. That's the question. If BD is an angle bisector. So if segment BD is an angle bisector, it means it's going to cut this angle into 2 equal parts, which means that this is also a 6x plus 3. Given another fact for this problem, the measure of angle ABC, that's this angle here, is 13x plus 4. Using the angle addition postulate, the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So here's what we're saying in the picture. This angle, the blue one, plus the red one is going to equal this green angle. If we substitute in with what we know, measure of angle ABD is 6x plus 3. Measure of angle DBC is also 6x plus 3, because that angle is being bisected. Measure of angle ABC, we were told, is 13x plus 4. So even though the question's asking us for the measure of angle ABC, we first got to figure out what x is. Combine like terms, 6x and 6x is 12x, plus 3 and a plus 3 is a plus 6. If we subtract 12x from both sides, we're going to get 6 equals x plus 4. And if we add 4 to both sides, we get x is 10. Once we know x is 10, we can try to focus on the question, which is find the measure of angle ABC. That is 13x plus 4. X is 10. So we're going to get 130 plus 4. So we get an obtuse angle, 134 degrees. Number 11. Last one. Segment AD is a perpendicular bisector. Well, perpendicular means forms a 90-degree angle. Those are both 90. Bisector means this is equal on both sides. And what we learned earlier today, well, the theorem that we had, if a segment is a median and an... Let me backtrack. This is a perpendicular bisector. Since that goes through a vertex, that makes this an altitude and a median. And when that happens, that means this has to be an isosceles triangle. An isosceles triangle theorem then says the base angles have to be congruent. Now, none of the last things I just did affect the problem, but it's things you got to look out for every time that this happens. So as far as equations we can write, 3x plus 7 equals x plus 15. Another equation we can write is that 2x minus 30 equals 90. You solve each of those little fellas, you're going to get 2x plus 7 equals 15, 2x equals 8, x equals 4. And the other equation, add 30 to both sides and divide by 2, and you get y is 60. Super important that you study your little heart out for the definitions of median, altitude, angle bisector, perpendicular bisector, and know this theorem from the bottom of your heart.